Welcome everyone. Let's begin our lesson for today by going over the learning goals and success criteria. First, what are we learning? We're learning how to factor a number out of a polynomial in order to simplify the expression, how to recognize a binomial as a difference of squares, how to factor a binomial into a difference of squares, how to factor polynomials with a coefficient of 1 into a product of binomials, and how to factor polynomials with coefficients greater than 1 into a product of binomials. How are we learning it? Through the Factoring Review Part 3 notes and the Factoring Review Part 3 assignment. When can we use this information? To examine problems from your life in different perspectives in order to find the best approach to simplify the problem. How do we know we learned it? By getting a score of 4 on the Factoring Review Part 3 assignment. Now let's take a look at our agenda for today. We will begin by going over the learning goals and success criteria. While we do that, you'll fill out your Get It Started. After that, we'll go over the Factoring Review Part 3 notes, and then I'll give you time to complete the Factoring Review Part 3 assignment. Once you've completed the assignment, we'll go over it together and answer any questions that you may have. At the end of class, we'll go back over our learning goals and success criteria while you fill out your Before You Go. Your only homework for tonight is to continue working on the quadratic study guide and any incomplete assignments that you may have. Let's take a look now at the Factoring Review Part 3 notes. The notes begin with the learning goals and success criteria. Understanding multiple forms of multiplication. So when we are multiplying two numbers together, particularly when one of them is a variable, we write them as joined together. So we write them like this. So we're multiplying 4 times x. So we write them joined together. We can also use parentheses to do this. So we can write 4 and then parentheses x. They mean exactly the same thing. They're just giving indication of multiplication. So distributive property. So it says, what would happen if we wanted to multiply 4 times 2 less than some unknown number? So instead of just being 4 times x, we want it to be 4 times some grouping of a number. So in this case, x minus 2. So we write it just like this, 4 times x minus 2. The distributive property states that we will multiply 4, so the number outside, by everything that's inside the parentheses. So this becomes 4 times x and 4 times negative 2. And then we can just go ahead and combine whatever terms we can combine at the end. So in this case, we get 4x minus 8. Because 4 times x is 4x, and 4 times negative 2 is negative 8. So then how do we solve something like this? X plus 4 times x minus 2. Well, maybe you heard of this term before. FOIL, which means first, outside, inside, last. So you multiply the firsts and then the outsides, so this one and this one, then the insides, then the last ones. Well, that might be what you've heard in the past, or maybe you haven't, but does it work for all polynomials? So can I do it with this? Now FOIL doesn't really help. So the easiest rule is multiply every term in the first one by every term in the second one. Pretty simple. So we take x and multiply it by x. We take x and multiply it by negative 2. Then that's all it for the x's. Now we do the 4. So 4 times x and then 4 times negative 2. And now we go ahead and combine these. So x times x is x squared. Negative 2 times x is negative 2x. 4 times x is 4x, and 4 times negative 2 is negative 8. Now we just combine the like terms. X squared, we have to leave that by itself, but we do have a negative 2x and a positive 4x, so we can combine those. So negative 2x plus 4x is positive 2x. So we get x squared plus 2x minus 8. So what about trinomials? So what if it's 3 terms? It's no different. We do the same thing. So we take x squared and multiply it by x squared. We take x squared and multiply it by 4x. We take x squared and multiply it by negative 6. Then we do it for the second term. Negative 3x times x squared. Negative 3x times 4x. Negative 3x times negative 6. And then we do it with the 2. 2 times x squared. 2 times 4x. 2 times negative 6. And this looks like a lot of stuff, but once we combine like terms, it shouldn't be so bad. So we get x squared times x squared is x to the 4th. We get x squared times 4x is 4x cubed. X squared times negative 6 is negative 6x squared, and so on. And we end up with this. Now we just combine like terms. So we're going to find all the x to the fourths. Well, this is the only x to the fourth. Then we find all the x cubes. Here's an x cubed, here's an x cubed. So we have 4x cubed minus 3x cubed. When we combine those, we just get a single x cubed. Then we do all the x squareds. Then we do all the x's. Then we do all the constants. And when we combine them, we end up with x to the fourth plus x cubed minus 16x squared plus 26x minus 12. Now factoring. Factoring is a term that means simplifying a problem by determining the factors of the expression. So we need to be able to pick out a common factor that exists within a number or a set of numbers. So in this case, let's just look at 36. What are the factors of 36? Well, we have 1, 2, 3, 4, 6, 9, 12, 18, and 36. These are factors because I can multiply all of these numbers by something and get 36. Or another way to look at it is 36 is divisible evenly by all of these numbers. So these are factors. So factoring is really just a reversal of the distributive property. For instance, with the distributive property, we had something that looked like this earlier. So we had 2 times x minus 4. Well, we multiply 2 times x and 2 times negative 4, and we get 2x minus 8. Now, if we were to factor this, we're looking for something that's in common between the two of them. Well, we know that 2x is divisible by 2 and negative 8 is divisible by 2. So I can pull that out and I end up with 2 times x minus 4. So really it's the same thing. So I just divided each of them by 2 and put that outside. So factoring in this way is exactly the opposite of the distributive property. So let's look at some examples. So we have x squared minus 4x. So we're looking for something that's in common that we can divide out of both of them. Well, we have an x in both of them, so we could divide that out. So when we do that, we have x times something is equal to x squared minus 4x. Well, we know that we need to pull out an x, so we're going to divide x squared by x. So x squared divided by x is just x. And then negative 4x divided by x is just negative 4. So we get x times x minus 4. Let's look at another example. We have x squared y minus 4xy squared. So we need to figure out what's in common. Well, we have a single x in common here, right? Because this x squared, there's not a squared here. So we can only pull one x out. And we have a y and a y squared. So we can pull one of those out as well. So we're going to pull out an x and a y. So we know that's what it's going to look like. xy times something is equal to this whole thing. Well, when we divide by an x, we're left with one x here. When we divide by a y, it takes the y away, so it's just 1. So all we're left with here is just an x. And then we have this minus 4, that stays. When we divide by x, the x goes away. And when we divide by y, we get just a single y. So we should end up with xy times x minus 4y. Let's look at another example. We have x squared minus 4. So we're looking for something that's in common. Well, all we have is an x here, and all we have is a constant here. So there's nothing in common there. So there's nothing we can factor out. So it's not factorable. So we just leave it as it is. So this is its most factored form for now. So what is a difference of squares? A difference of squares is subtraction of two terms that are perfect squares. For instance, x squared minus 1. So remember, difference means subtraction, so it's got to be subtraction. And each of these numbers needs to be a perfect square. Well, we know that x squared is the quantity x to the second power, and 1 is just 1 squared. So this is a difference of squares. So this would be an example. So how do we factor a difference of squares? We're going to use the following methods. So anytime we start with something like this, and we have a number squared minus a number squared, it becomes a plus b times a minus b. Okay, so it's just something you have to memorize. So a squared minus b squared is equal to a plus b times a minus b. So let's look at an example. X squared minus 4. Well, if we rewrite this, if we put it in this form, this is really x squared minus 2 squared. So when we write that, we would write x plus 2 times x minus 2, and that would be our factored version. So look at another example. We have x squared minus 4. We said that that is... So let's check our work by distributing. So we said that x squared minus 4 is equal to x plus 2 times x minus 2. Well, let's go ahead and distribute this and see if it works. So we're going to multiply x times x and x times negative 2, and then 2 times x and then 2 times negative 2. So we get x squared here minus 2x plus 2x minus 4. We combine our like terms. Negative 2x plus 2x is just 0, so this becomes x squared minus 4. So we did it correctly. Let's look at another example. We have 25x squared minus 16. Well, 25x squared is really 5x squared, and 16 is really 4 squared. So we can rewrite this as 5x plus 4 times 5x minus 4, and that's our factored version. So again, another example, 25x to the 4th minus 16. Well, we have a power of 4 here, but is that still a perfect square? Well, we know 25 is a perfect square, and then x to the 4th is really x squared squared. So we can go ahead and enter that in. So this is 5x squared plus 4 times 5x squared minus 4. And that would be our difference of squares. Another example, 3x squared minus 12. Well, we can see that 3 is not a perfect square and 12 is not a perfect square. However, we can see if we can use our method from yesterday as well. So we can see if we can factor out a common factor first. So is there anything in common between 3 and negative 12? Well, we can see that 3 is a factor of both 3 and negative 12. So let's go ahead and factor that out. So 3x squared divided by 3 is just x squared, and negative 12 divided by 3 is negative 4. Well, now we have this 3 here. Now we have a difference of squares inside the parentheses, so we can factor that. So this is really x squared and 2 squared. So this would be x plus 2 times x minus 2. So this becomes 3 times x plus 2 times x minus 2. Now, what is a quadratic? A quadratic is an expression or equation that is of this form: ax squared plus bx plus c. So notice the squared term is here, that we have an x squared, and we have some other x and then some constant. A, b, and c are all numbers, so those are not actually variables. So an example would be 3x squared plus 2x plus 4. That would be an example of a quadratic. So if I ask you to factor this quadratic, x squared plus 5x plus 4, the solution is going to be of this form: x plus m times x plus n, and m and n will be some number. So we need to figure out what numbers need to go in these two spots. And the way we do it is by using the x method. So we're looking at the same question, and here's what we do. We place c in the top. So c is 4, so this goes up here. Then we place b in the bottom. b is the middle number, so this goes here. Now we're going to write out the factors of c. So what are the factors of 4? Well, we have 1, 2, and 4. So those are my factors. Now I need to figure out which two of those numbers are going to multiply to equal 4 and add to equal 5. Well, I have 1 times 4 is 4, and when I add those two together, I also get 5. So I'm going to go ahead and put each of those in each of these sides. It doesn't matter which one goes where, as long as I have 1 and 4 on each side. Then I'm going to place those two values into the solution. So I start with x plus m times x plus n. I'm going to plug 1 in for one of them and 4 in for the other one. So I get x plus 4 times x plus 1. And that would be my solution. Let's look at another example. We have x squared minus 6x plus 8. So same thing, place c at the top. So c is 8, so that goes here. Place b in the bottom, which is negative 6. So that goes there. Then I'm going to write out the factors. What are the factors of 8? Well, I have 1, 2, 4, and 8. Now, which of those are going to multiply to equal 8 and add to get negative 6? Well, remember, these can be both positive or negative. So I'm looking at negative 1 times negative 8 is positive 8, but it's also equal to negative 9. So that's not the answer. What about this one? So negative 2 and negative 4. If I multiply those two together, I get positive 8. And when I add them together, I get negative 6. So that would be my solution. So it's negative 2 and negative 4. So I place those in my x and then add them to my solution, which started as x plus m times x plus n. Well, I'm going to plug in negative 2 for one of these and negative 4 for the other one. So I get x minus 4 times x minus 2. One more example. We have x squared minus 4x minus 12. Well, I place c at the top, which is negative 12. I place b at the bottom, which is negative 4. Then I write out the factors of c. So what numbers multiply to get 12? Well, I got 1, 2, 3, 4, 6, and 12. Now I need to find two numbers that multiply to equal negative 12 and add to get negative 4. So I know in order to get a negative, when I multiply, one of them has to be positive, one of them has to be negative. So one of these has got to get me close to 4. So if I do this, I have 2 and 6 are 4 away from each other. So I just need to make sure that when I add them, the bigger number is negative so that it stays negative. So I'm going to make this negative 6 and positive 2. When I multiply those together, I get negative 12. When I add them together, I get negative 4. So I go ahead and add those to my x. Then I place them into the solution. So I start with x plus m times x plus n. And then I'm going to plug negative 6 in for one of them and 2 in for the other one. And I get x minus 6 times x plus 2. Now what if the a value is not 1, like in the previous examples? So in this one we have 5x squared minus 18x plus 9. Well, we're still going to use the x method, but we have to add a little bit to it later on. And this becomes the x box method. So the way we start is we're going to multiply a times c and put that in the top. So 5 times 9 is 45. And then we put b in the bottom just like before, so that's negative 18. And then we're going to write out the factors of a times c. So what are the factors of 45? Well, we can see that the factors are 1, 3, 5, 9, 15, and 45. So now which one of those is going to add up to be negative 18? Well, this is positive, so we know that they have to match. The signs have to match. So we need two of them that are going to add up to be 18, which we can see would be 3 and 15. So that would be negative 3 and negative 15, because that'll give us negative 18 total. So we have negative 15, and this should be negative 3. Now we're going to do the box part. So that's the x part. Now we're going to do the box part. So we're going to make a table with 4 squares, just like this. And we're going to place ax squared in the top left box. So that's 5x squared. So that goes here in the top left. Then in the bottom right, we're going to put c, which is 9. So that goes there. Now we're going to place negative 15x and 3x into each one of the boxes. And it doesn't matter which one you place it in. So we'll put negative 15 there and 3x here. Now we're going to factor out what we can, trying to find a common factor. So between 5x squared and 15x, there's a 5x in common. So that's what we would factor out. So we'll go ahead and just put it at the top of the box. Then we'll do this one, 3x and 9. Well, 3 is in common between those two, so we'll put a 3 at the top. Then we go crossways. So we have 5x squared and 3x. Well, the only thing in common there is an x. And then 15x and 9. Well, we have a 3 in common there. So now we have 5x and 3 and x and 3. And now we just place it into our solution. And now we're just going to check the signs to make sure they're correct. We know that the signs need to match so that it's 9, which they do here. And we need to make sure that we add up to be negative 18. So this is 5 times negative 3 is negative 15, minus 3 is negative 18. So we did it correctly. Let's look at another example. We have 2x squared minus 11x plus 15. So again, put a times c in the top. So a times c is 2 times 15 is 30. And put b in the bottom, which is negative 11. So we need two numbers that multiply to get 30 and add to get negative 11. So we write out the factors of 30, and we get 1, 2, 3, 5, 6, 10, 15, and 30. Well, we know that 30 is positive, so then we need to have two numbers that are both the same sign, which add to get negative 11. Well, 5 and 6 gives us 11. So if they're both negative, that would give us negative 11. So this would be negative 5 and negative 6. So we go ahead and place that there. Now we move to the box part. So there's our box, and we put in ax squared here in the top left. So this is 2x squared. And we place c in here in the bottom right. So that's 15, so that goes there. Then we place these parts here. So negative 5x and negative 6x go in each of these boxes. And again, it doesn't matter which one goes where. So there we go. Now we just need to figure out what the common factors are. So we'll start here. 2x squared and negative 5x. Well, the only thing we have in common there is x. And then we have negative 6 and 15. Well, they have a 3 in common. Then here we have 2x squared minus 6x. Well, we have a 2x in common. And then 5x and 15 has a 5 in common. So we have x minus 3 and 2x minus 5. And we place those into our solution. So now we have 2x minus 5 and x minus 3 as our answer. Now there's a video here using Symbol Lab to show you how you can check your work with factoring. So go ahead and watch that video. Let's talk now about how we can use the Symbol Lab factor calculator to factor polynomials. So if you notice, I am on Symbol Lab, and it does say that this is the factor calculator. So when you do that, the word factor should already be here. And now I'm just going to put in the equation that I want to factor. So let's say it's x squared minus 4. So that's what I'm going to put in, and I'm going to go ahead and click go. So when I do that, it gives me the answer down here at the bottom. X plus 2 times x minus 2. And it shows me the steps of how I can get there. So this is one way to check your work to see if you did your work correctly when factoring. So this is how Symbol Lab Factor Calculator can help you with your factoring. Let's take a look now at the Factoring Review Part 3 assignment. The assignment begins with the learning goals and success criteria. If we scroll down, we can see the questions. The first one says, what is the greatest common factor of the expression? Well, we can see that 2x minus 4, there's a 2 in common. So the greatest factor is 2, so we go ahead and mark that. And it's going to continue to ask about the greatest common factor. Now let's look at this one here. So now we're actually factoring the expression. So it says 2xy squared z minus x cubed y squared z to the 4th. Well, the 2 we can't factor anything there because they don't have anything in common. We have an x in common here. We have a y squared in common here. And we have just a single z in common here. So we should have x, y squared, z as what we're factoring. So this has an x, y squared, z. And then what we're left with is 2. The x is gone, the y squared is gone, the z is gone. So it's just 2. And then we factor out an x, so we're left with x squared. The y squareds are gone, and we're left with z cubed. So that's this one here. So we'll go ahead and mark that as our answer. And we'll continue to answer all of these until we get to the end. When we get to the end, go ahead and click Next. This will take you to your Before You Go. Go ahead and fill out your Before You Go and then submit your work on Google Classroom.